Good people, sanibonani, Makebalo. Today we are continuing from that paper that we are still doing, grade 10, November 2019. So these are the questions that we'll be dealing with in this video. Make sure you watch it until the end. Now, let's get into it. On this first part where it's 2.1, now here they're asking us to solve for x. Now, I hope you can see if here solving for x, let me write it down. So it's 2.1.1, so it's 2x squared minus 10x is equals to 0. Now, from here, I hope you can see now there is 2 and 10. Is there a common factor between 2 and 10? Yes, there is a common factor of 2. Now, if I take 2 as a common factor, there is a common factor between x squared and x. Yes, there is. So the common factor between these two is 2x. And then if I take 2x, what is left here? 1x is going to be left here. So I took 2 out of these 10. So what is left is going to be left minus 5. Then bracket is equals to 0. And then from here, this is going to be equals to 0. So 2x is equals to 0. And x minus 5 is equals to 0, which is divided by 2. So it's going to be 0. And then here, transpose 5 is going to give me 5. Now, let's get into that one. So 2.1.2. So now p x minus k is equals to k minus p. This is x here. Now from here, I hope you can see what I have here. I have x and x, which is what? Which is a common factor. So if I take x as a common factor, so I'm left with p minus k into k p. Now, from what I have here, this thing more or less looks the same, but they don't look the same because here we are starting with k and p and k, and the signs, this k is positive here, this k is negative here. So how can I make these two to be the same? So if I can take a common factor of negative here, and then after that I just swipe my k and my p. So if I can keep this outside there and then minus into now k, if I times this and this, still gonna be negative. Now from here, p here, for this p to be positive, this one there's gonna be inside here needs to be negative. So this and this give me this, this and this give me this. Check is very, very important. And now it's gonna be k minus p. And then now this x is gonna times this negative. So I'm gonna have negative x into k minus p into k minus p. Then from here, I can divide by k minus p, and then I can divide by k minus p. And then this cancels this, and then I'm having a negative x is equals to now this and these are the same also. So I'm left with 1. Remember, I'm looking for x, not negative x. So I'm going to divide by negative or times by negative. So my x is going to be equals to negative 1. I hope we are still on the same page there. Now let's get into 2.1.3. So now in this one, I'm having 2 into, let me write it correctly. So I'm having x all over 3 equals to over 128. So now from here, if I can keep this for now, so it's going to be 2 into x over 3 all over 1. Let me deal with this 128. No, is from the prime factor of 128 is going to be 2 into 7. And then now from here, this base of 2 is on the denominator. So if I can have to take it into the top, the sign of the exponent is going to change. So I'm going to keep this as 2 into x all over 3 is equals to now 2. This goes to the top, the sign is going to change, so it's going to be minus 7. And then from here, same base, if I having the same bases, and then I take the exponent. So x all over 3, and then is equals to negative 7. And then from here, I cross multiply. So it's going to be x is equals to this 7 is going to times this 3, sorry, is going to times this negative 7, and I'm going to have negative 27. So sorry, not to negative 27, but it's 1. So my answer here it's negative 21. I hope we're still on the same page there. Now, let's get into this one here. First thing also, we're still asked to draw or to solve for x based on this inequality equation that we have there. So we're going to have x plus 5 all over 2, and then this is greater than negative 2. Okay, this is 2.2.1. So now from here, to solve this inequality, first thing, cross multiply. So this is going to times that. So I'm going to have x plus 5 into greater than negative 4. And then from here, I take this to the other side, and then becomes what? Becomes negative. So it's going to be negative 4 and negative 5, which is going to be x greater than negative 9. Now from here, this is the solve of x, which is they were asking me in 2.2.1. Now from there, they are saying if x is an element of all real numbers, represent the solution of 2.2.1 on the number line. Now what is very important here, this is my number line, and I'm going to have my 0 there, or my dot that is not shaded, because I'm not including the number 9, the negative 9 there. Now from here, I'm having negative 9 here. So here they're asking me that the values of x are bigger than negative 9. So from here, which are those values that are bigger than negative 9? Are the values on this side, or are the values on these sides that are going to be bigger than negative 9? So negative 9 is smaller than those values of x. So from what I'm seeing here, the values of x that are bigger than negative 9 are the values going this direction. So my negative 9 is smaller, or it's less than the values of these x that are going this direction. So this is what we are having to write based on the number line. Now 2.3, now here they're saying solve simultaneously x and y. So I'm having x into x minus 3 into plus y into 3 minus x, and then equals to 0. Now from here, I hope you can see now that this and this look more or less the same, but they're not the same. But we usually start with the variable and then followed by a number or a constant. But what is happening here, we're starting with the constant or a number and then left with the variable. So probably there is something that we can do here that can make this look the same as this. I hope you understand. There is something that we did previously in terms of making these things the same. So we're going to apply the same logic here. So if I'm having the x here into x minus 3 and then plus, and now here, if I can just take out the common factor of negative, and then I swap the two, and I say this x, now this and this has to give me this, so this has to be positive here. And then now for this to be positive again, needs to be negative, because this negative and this negative needs to give me the positive here. So it's going to be negative 3, and then bracket, and then is equals to 0. So now from here, so going to be x minus 3, and then this positive y is going to times this, and then we're going to have negative y, and then into x minus 3 is equals to 0. I hope you can see now that this and this are the same, so we can take what? A common factor of what's now of x minus 3. And then if I take this as a common factor, what is left? I'm left with this x here, so it's going to be x. This I've already taken out as a common factor, which is this one, so I'm left with what? Minus y is equals to 0. Now remember, I'm still solving for x. Now, based on factorization, because we are factorizing here, after here, I can say now this is going to be equals to 0, and also this is going to be equals to what? 0. So x minus 3 is equals to 0, or my x minus y is going to be equals to 3. Now from here I can solve my x here by saying x is going to be equals to positive 3. Now I know my x here. Since I know my x, I can take my x and substitute it here in order for me to get y. So if I can say now this is 3 minus y is equals to 0. Now let me take my y to the other side. So my y is going to be y is equals to 3. So this from here comes here. So I hope you can see now how to solve this simultaneously. After solving my 3 here, substitute my 3 into this x and then solve for y. I hope we are still on the same page there. Now let's come into this one, which is the big question from this question 2 that we're having here. Now let's read the instructions that we have in here. They're saying during the fundraising event, only 10, 20, 50 notes were collected. Now, from that first statement, okay, let me continue. In the final account, there were twice as many 20 Rand notes as there were 50 Rand notes, and 50 more 10 Rand notes than 50 notes. Now, if I can if 10,150 was collected in total, now let's determine the number of 10, 20 note that were collected. First thing, let me just let x be the 50 note and let y be 20 note and z be the 10 Rand note. So now, from the equation that I can form here, remember they told me that there were twice as many 20 Rand that were in the 50 notes. So if I can say now y is equals to 2x, based on this, there were twice as many 20 Rand than there were in the 50 Rand notes. And then from there, I can say Z is going to be equals to, now this is very important. Now there were 50 more 10 Rand notes than 50 notes. So here I can say now this is my x plus 15 based on the following statement there. So this one was based on the first statement. There were twice as many 20 Rand notes as there were in 50 notes, which is give us this equation. And then the other one is saying 15 more 10 Rand notes than 50 notes, which give me this statement that is there. Now remember here, now they told me that total was collected was this. So now if I can say now 50x plus 20y and then plus 10 Rand Z, in total we are having 1050. Now from here, remember I have this equation, so whenever I see y, I know is equals to 2x, and the moment I see z, I know that is equals to x plus 15 based on this, the equation that I formed from this my statement. So here I'm going to keep it as 50 x and then plus 20. Now I know y is equals to 2x and then bracket and then plus 10 into, remember z I know is x plus 15, and then I know this is equals to my total 150. So from here, if I can add, so first thing, let me keep this as this, and then this times this is gonna give me 40x, and then timesing here by opening the bracket is going to be 10x, and 10 into 15 is going to give me 150 is equals to 10150. Then from here, adding this like terms that has x in it, it's gonna give me 100x. Then is equals to, now taking this 150 to the other side, so it's gonna be this total minus 150, which is gonna give me 10,000. And then from here, I can divide by this 100, divide by this 100, so my x is equals to hundreds. Now, finding my value of y, and because I know x now, so I can say y is equals to 2 into 100, which is giving me 200, and then z is going to be now 100 plus 15, which is going to be giving me 115. Now, if I can conclude, now I can say that there were, there are 150 Rand notes. Based on here, also I can say now there were 200 of the 20 Rand notes, and also I can say there were 115 10 Rand, oh sorry, 10 Rand there. 10 Rand of the note that they were had in order for them to fundraise this event. Hopefully we did understand everything that we did in this question. Thank you so much for watching the video. Makebalo.